Hello everyone, and welcome back to Intro to College Chem. Today we're going to be covering SI units and their prefixes, or just getting a better understanding of units today. So first we're going to see length, which the unit for it is always going to be meter, or having to do with meter. For mass it's going to be gram. For time it's going to be second. There are some variations there, but it always kind of is related to seconds or the accumulation of seconds. Temperature, it's going to be Kelvin. Kelvin is the most important one you need to know in terms of calculations later on, especially in general chemistry. But it's also a good thing to know Celsius and Fahrenheit and how to convert between them. If you'd like to know how to do that, you can click on the box above. Also, Kelvin and Celsius have a really easy conversion, so that's cool. And then for the amount of substance, that would be moles. And moles are really relative to that substance itself, and you'll see that later on in the course as well. So let's actually kind of understand why there will be some variations within the units and why there's prefixes. So let's say we have 1 meter, right, which is about 3 footsteps. If you know a person is 1,000 meters away from you, that's a really good thing that you know that it's exactly 1,000 meters, because that's very precise. However, if you have to do any distance that is longer than this, it gets really impractical, because then you'd be counting 1 meter at a time. So let's say you have to cover a distance that is way larger than 1,000 meters. Well, you have to count one each individually, right? Or at least write it down as a big number. And when doing calculations, having a big number is also kind of less efficient or less fun to work with, I would say. So that's why in this case 1,000 meters is 1 kilometer, and especially if you're calculating a distance that's like a road trip, which is multiple, if not in the hundreds of kilometers, then that's way more practical than doing like 10,000 meters or 11,000 or 12,000 or however many meters that you would have to do. And this same applies for units that are, or calculations that are smaller, right? So here you can see a blade of grass, and the length of it. And you know that it's way less than 3 footsteps. So in this case, if you're, trying to get this measurement in meters, you'd end up with a really weird looking fraction, like 0.01, and you don't know how long it really might be. So that's why there's also, you could go the opposite way and make your base unit smaller, like centimeters and millimeters, and then you can choose the precision that you would like. So that's the importance of the actual base units and their prefixes, which we can take a look at now. So these are the SI prefixes, which kind of determine how small or how big each unit is going to be. And this goes back to scientific notation, which if you remember. So the only ones you're going to need are the ones that are in mint color, as you can see here. And yeah, for this course, you're only going to need usually these. In terms of, it's always going to go smaller, but the only times that it's going to go bigger is either going to be mega or kilo. Like I already said, kilo is 1,000 10 to the third. Like 1 kilometer is 1,000 meters. 10 to the 6 would be mega, and that would just be 100,000 per one. So yeah, one way to remember these right here, what I'd like to do is just kind of make a mnemonic device. And what I did was like Derek cooked mighty meat nicely because of you. Something that just sticks to your head. The crazier it is, the easier it is to remember. So yeah, and then once you have that, you can kind of remember each word with what factor it is, what symbol it is, and it's easy to remember that way, because once you actually remember these, once you actually have to solve problems, it gets way easier, and you just remove the chance of getting the answer wrong because you forgot how to do the calculation. So let's do some like sample ones. Here's like a table format. So let's say we have to do 800 centimeters to meters. So like we always like to do, let's start with what we have, which is 800 centimeters. And let's look at the conversion that we have here. If we look down here, 1 centimeter, or 1 meter, or no, 1 centimeter, my apologies, is 10 to the negative second meters, right? That's the factor for it. So we can set it up like this, like a normal cancellation, right? So we have 800 centimeters, and we have to cancel with 800 centimeters, or just centimeters at the bottom. So we would do on top, we want to go to meters, so it'd be 1 meter, or my mistake, 1 centimeter is 10 to the negative second meters, like so, right? So now we've successfully canceled out centimeters, and now all we have to do is complete the multiplication, which in this case, if we pull out the trusty calculator, it would be 10 to the negative second, so we're going to have to divide by 10 to the second, and that'll be 8 meters, and there you go. So that'll be your final answer for that one. So as you can see, the conversion holds true. 800 centimeters would be 8 meters, and the conversion is 100, right? So per every 100 centimeter, you're going to have 1 meter. All right, so now let's go ahead and do the next one. And the other one is going to be blank decigrams, right? And we can see that it's decigrams based on the symbol, right, down here. It's going to be blank decigrams equals 5 grams. All right, so let's set it up again. So we have 5 grams to start with, and we need to go to decigrams, right? So dg. Okay, so what do we know? We know that 1 dg, right, as we can see down here, is 10 to the negative 1 meters. So we use that same conversion. 10 to the negative 1 is, or meters, like so. And, or, my mistake, 10 to the negative 1 grams. So now we've successfully done the cancellation yet again. Cancel out grams, and we're going to end up with decigrams, right? Alrighty, so now let's actually do the calculation. 10 to the negative 1. So that's going to have to go up, and it's just going to be 5 times 10. So 5 times 10, our answer is going to be 50, right? And there you are. Your answer is 50. Once you kind of understand how the conversions work, you get to see that all we're doing, like as we did in scientific notation, is moving to the right or to the left in decimal places. So we know centimeters is a way smaller measurement, right? Centimeters is a way smaller measurement than meters, right? So when we have 800 and we're going to meters, we know that the measurement is going to be smaller, right? The unit's going to be smaller, and we just have to know by how much, and that's where the actual conversions can come in handy. All right, so let's do these last two before we move on to actual like word problem setups. So the next one is going to be 4 megaliters, right? A capital M, as we can see down here, is going to be mega. 4 megaliters into liters. Okay, so this is kind of a different one. This is going from bigger to smaller in the sense that the prefix actually makes it bigger. Okay, so let's start with what we have, like we always do, 4 megaliters, and we have to go to liters. All right, so let's set up the calculator, or the conversion yet again. And as we can see down here, the conversion is 10 to the 6, right? So 1 megaliter is 10 to the 6 meters, right? Okay, so, or liters. All right, so here we have, down here, we're going to do 1 megaliter is 10 to the 6 liters. And there you go. All you have to do now is complete the conversion. 4 times 10 to the 6, and that'll give you 4,000,000,000. There you go. And as you can see, all we did really is move to the right. We moved to the right 6 times. So we started here, 1, 2, 3, 4, 5, and 6, and there you go. So in this case, I kind of can't make it fit in here, so all I'm going to do is leave it in the way that we multiplied, and we'll do 4 times 10 to the 6 liters. All right, scientific notation coming in handy. All right, so now we're going to do 6 seconds to milliseconds. Okay, so let's set up our problem like we always do, starting with what we have. So we have 6 seconds, and we have to convert to milliseconds. So let's do the cancellation. Seconds on the bottom. 1 millisecond is, we have to take a look at the chart. Millisecond is 10 to the negative 3, right, of 1 second. Okay, so 1 millisecond is 10, 10 to the negative 3 seconds, right? Just like so. So now, all we have to do is complete the calculation. Again, negative exponent, that means it's going to go to the top, and we're going to multiply it by 10 to the third. So 6 times 10 to the third, and we're going to get 6,000 milliseconds, right? So 6,000 milliseconds makes up 6 seconds, and that makes sense, right? Okay, so now that we kind of have an understanding of how the conversions work, let's continue and do it in kind of like of a problem, all right? So engineer, right, measures the capacity of a power plant. The capacity is 755 megawatts. What is the capacity in watts? Use scientific notation. Okay, so in this case, our answer will have to be given in scientific notation. But, as always, let's just start with what we have. So 755 megawatts. What do they want it in? Just normal watts. So we have to get rid of the prefix, which is mega, right? So let's set up the conversion. 755 times megawatts is going to have to be on the bottom to cancel. So it's going to be 1 megawatt is, take a look at the chart, mega is 10 to the 6. So 1 megawatt is 10 to the 6 watts, right? And they want it in scientific notation. So in this case, we don't actually have to multiply, and we can leave it the way it is. We can do 755 times 10 to the 6 watts. Now, if you want to be more scientific notation, savvy, preferably you'd want to do it with just one decimal place here, right? So in that case, we would do 7.55. And since we moved to the left by 2 units, or 2 decimal places, we'll do 755 times 10 to the 8 watts, and that's the same value. You can calculate these two, and it'd be the same thing. I was just doing it to get the decimal place in the right place, so it could be technically more correct. So that would be your final answer. Let's do one more. A scientist measures the thickness of a leaf to be 4.7 millimeters. So this one has to do with smaller. All right. What is the thickness in meters? Write your answer as a decimal. All right. So in this one, we're not doing scientific notation. We're just doing the conversion and seeing what the calculator gives us. So we have 4.7 millimeters, and we're going to set up the conversion yet again. And this time we're just going to normal meters, right? So we have to get rid of the prefix. The prefix we had has to go at the bottom to cancel, so 1 millimeter. And if we look at the chart yet again, we have 1 millimeter is 10 to the third, or 10 to the negative third meters. So 10 to the negative third meters. 1 millimeter is 10 to the negative third meters. Okay, so now we can do the calculation. 4.7 times 10 to the negative third. We're going to be dividing by 10 to the negative third because of how negative exponents work. So 4.7 divide by 10 to the third, and now we get 0.0047 meters. And there we are. That would be our final answer. So there you go. Main thing you have to know is to remember the specific factors in which you have to change the actual units and their conversions and what each prefix means, and you'll be good to go.